number three is just manipulation of equation. Yeah, this is one way of solving, well, applying a particular equation in solving a particular problem, because um, this is just for consistency of your final answer. If you're gonna do, like, if for example for letter A you're solving for I know that mostly what you will be doing is that just substitute first and then solve, right? But in some cases you can get the expression for VI first and then before you substitute. It's just that if you're gonna do it that way and then do all the calculation in one setting, it will give you closer to the uh, answer without necessarily going through, like, rounding off along the way. So you're just rounding off in the final answer. So yeah, that's just the purpose of this one. But it also shows your um, comfort in with your algebra. So let's take letter A. So for letter A, we're going to solve for VI. So if you will be asked to solve for something, just a way of saying you need to isolate. You need to isolate VI. So that means that either side of the equation, you have two sides of the equation, the left and the right. So all your aim is to isolate your VI. That means that you need to have VI in one side of the equation only. Okay, so that's your aim. So how do we do that? Well, we will employ the things that we know in algebra. Okay, so you have here D is equal to BF plus BI over 2 times T. So maybe what you did here, some of you, you tried to divide both sides by T. Okay, because doing that, I can isolate my T, because T over T is just equal to 1. It's not 0, okay? It's 1. So that would lead me to D over T is equal to VF plus VI over 2. But in this particular form here, I cannot isolate directly my VI because of the 2 at the bottom. So I need to deal with that one first. Well, to do that, I'll be multiplying both sides by 2. Because if I'm going to multiply this by 2, 2 over 2 will give me 1. So again, this is 1, 1. So essentially, the 2 will be gone there. But the basic rule in solving equation, just to balance out your equation, whatever you do on one side of the equation, you also try to do it on the other side. So essentially, this will lead you to 2D over T is equal to VF plus VI. Okay? So now, if you can see here, I get rid of the T and the 2. So I'll just go directly to, how would I separate this VF? That means that I want to eliminate VF on this side. Well, is it not that I can do that by subtracting this by VF? Okay, because VF minus VF gives me 0. That means that it will be gone. However, again, to preserve my equality, whatever you do on one side, you also do it on the other side. So this will lead me to, so if you can see here, 2D over T minus VF, well, I cannot combine the two because they're dissimilar terms. Again, you can only add or subtract similar terms. So if that happens, well, I just write 2D over T minus VF, because I cannot combine, again, 2D over T with VF because they're dissimilar terms. They're not similar terms. So if you can see here, essentially what I got is VI on one side. So that would be my final answer. Okay. So VI is just equivalent to, or if you want to write it in a conventional way, wherein it is in the left-hand side, you can just interchange them. So as long as they're already separated, you can actually do this one here. Just the same thing, okay? They're already isolated, so that means that, yeah, you can just their placement, okay? So they're just essentially the same. VI is equals to 2D over T minus VF. It's just the same thing with 2D over T minus VF is equal to VI. So essentially, this is now isolated. So in this sense, these are isolated. Your VI is already on one side of the equation. So that would be your aim. So if you want to manipulate the equation, just remember that you'll just be given the set of equation in physics or any other physical sciences subject. However, it's up to you to look for, let's say, for example, for speed, it's simply as distance over time. However, sometimes you're given the speed and the distance, you need to solve for the time. So same thing with this one. Originally, the one that is given to you is the displacement formula, but you need to solve for the initial velocity. Okay, let's take letter B. So you have here, the energy is Well, this is total mechanical energy, kinetic plus the gravitational potential energy. But you need to solve for M. Again, just think, I need to isolate my M. So M must be isolated. So if I'm gonna isolate my M here, well, the first thing that I'm gonna do is I can factor out my M. You can do that. M would be v squared over 2 plus gh. Okay, you can do that. And in a way, if I'm gonna divide both sides by the same exact term, that means that I can cancel that one out. So that means that if I will do like v squared over 2 plus gh on both sides, okay, I can cancel this one out here. So leaving my m on one side. So you have here e over v squared over 2 plus gh is equal to n. Well, that's good enough actually, but conventionally we will try to simplify this further because this looks like a complex fraction here in the side. Okay, well, again, this is already good enough. I would accept this answer here. However, conventionally, I will simplify this one further by getting rid of this complex fraction. So I can express this one as just simple e over something. Okay, so I will get rid of the 2 at the bottom. So if we're going to extend this into that, the first thing that I'm going to do if I want to simplify my complex fraction is uh, to deal with the one that makes this complex is the bottom part. Okay, so I will combine v squared over 2 plus gh. So I'm going to make them as a single fraction. And I can do that by making their denominator equal to 2. So is it not that this is just the same thing as 2gh over 2? Okay, so remember that 2 over 2 is equal to 1, so that cancels out here, and that v squared over 2. So if you're wondering, this one here, how did I get that one? That is coming from, is it not that v squared over 2 plus 2gh over 2? It's just the same thing as v squared over 2 plus gh. Okay, again, I want to remember that you can only combine the numerator if they have the same denominator. So that's what I did here. So essentially, that is just equivalent to that. And is it not that this is E energy over this another fraction form? However, if I'm gonna get rid of the 2 there, this oops, okay, so this is equal to m, but this should just be equal to 2e over v squared plus 2gh. Okay, so if you're wondering how did I get that from here to here, well, this is just the same thing as, so this is just the same thing as e divided by a particular fraction of v squared plus 2gh over 2. And is it not that if you're dividing fraction, this is just the same thing as e over 1 multiplied by the reciprocal of this. Reciprocal of v squared plus 2gh over 2 is 2 over v squared plus 2gh. So if you're going to do that, that leaves you 2e over v squared plus 2gh. So that leads you to this one here. Okay, well, that is just a good looking way of expressing your final answer. But this one here is already enough. I would accept that answer. This is already fine. But extending that one to look at more neat, so you can express it this way. Okay, lastly here you have solving for k. So same thing, we need to isolate k. But remember, the k is inside this radical symbol of square root. Okay, so the first thing that you need to do is get rid of that square root symbol first. Okay, how would I do that? Well, if you can remember in your math 8 or maybe in math 9 or 10, to get rid of the square root symbol, I'm just going to take the square of that. If I'm going to take the square of a square root, remember that that square root will be gone. It's not necessarily it will be gone because that's, well, what happens there is that square root times square root means raised to the power of 1/2. And if you're going to square the power of 1/2, that leaves you 2 over 2, which gives you to the power of 1. So essentially, that leaves you x squared is equal to 2e over k. Okay, so remember, K is part of the square root. That's why when you try to take the square also of that, that means that the square root symbol of your denominator will also be gone. Okay. So now I need to solve for K. So K should be placed on one side. So to do that, I need to find a way to make my K at the top. So make it in the numerator because this is in the denominator. And I can do that by multiplying both sides by K. So this will lead me to K x squared is equal to, well, K over K is just equal to 1. Again, it's not 0. So that leads me to E. But I'm solving for, again, K. That means I need to isolate my K. So I'm going to divide both sides by x squared. So doing that, that leads me to K is equal to 2E all over x squared. So that would be my final answer. This should be an equation for, maybe this is an energy of a spring. So that leads you to that. So